Well, hello everybody. I hope you guys are doing well. Sorry I can't be there with you today, but we are going to continue on day 2 with quadratics. So here we go. So as you can see, I've got everything laid out for us here. So here's your question of the day. I'll go ahead and zoom in on that. Just a couple true-false questions here. So think them through. Pause the video if you need to. Figure out if you like true or false. For these, come back and then I'll yap about them for a little bit. About why they are true and or false, and then we will go from there. So go ahead, pause the video, and then when you come back, you'll see the answers, and then I'll talk about them real quick, and we should be good to go. Today is going to be kind of hard because you're not going to be able to see the graphing calculator. So if I say, hey, let's graph it, and let's look at values and do that thing, go ahead and pause, stop the video, graph it, and do all that, and it should make sense. But anyway, pause this, and then when you come back, you'll see a couple answers. Okay, welcome back. So first one, 2x squared minus 3x plus 2 would definitely, we could put that into our graphing calculators. We could graph it. By all means, it would pass the vertical line test. So that one's good to go. Number 2, the path of basketball when shot takes could be considered a parabola. So, yeah, we could. I mean, if you think about, here's the hoop, here's the backboard, here's me, and I'm shooting a basketball. Of course, it goes in. Yeah, we could think of that. That's not a very good parabola. But yes, that would be true. All right, so we'll like that. And last one, some of you might be scratching your head going, wait a second. I thought B over 2A was. Look closely, guys. Look closely. Only one little thing that makes this not true. Remember, it is the opposite of B over 2A. Right? That's our axis of symmetry there. All right? So there we go. Okay. Awesome. Onward we move to today. Okay, so in today's notes, we got a whole bunch of stuff going on. And hopefully it goes well for you, even though I'm not going to be there. But we're talking about today 8.3. So here, let me zoom in so I can write a little bit here. So our main topic today is all about roots. So we will call these quadratic roots, right? What are quadratic roots? Yep, just like the roots that grow on a tree. So what are roots? Well, by strict definition, I would say these are the points where the parabola intersects with the x-axis. So intersects the x-axis. Bam. Okay. We also have a couple synonyms for these. So they are also known as, and we've got a couple different words here. Of course, if they're intersecting on the x-axis, of course, the easy one we could think of is these are x-intercepts. X-intercepts. We can also call them solutions. We will also call them zeros. Okay, so again, these are, we can say the word roots, all right, or I can say any of those other ones, x-intercepts, solutions, zeros, and I'll try to do a good job to get you used to all of them, but they all mean the same thing. So these parabolas that we looked at yesterday, right, they've got that fancy curve to them, and sometimes they open up, sometimes they open down. Regardless of them, regardless of how they open, I should say, Sometimes we're going to have one of these three scenarios here. Sometimes these quadratic functions will have two solutions, one solution, or no solution. It all really depends on what they look like. Okay? If it has two solutions, it could possibly look, right, just like this. Ooh. If I can draw, there we go. Goodness gracious. Okay, that is awesome. Right, there we go. Okay, and my two solutions are right here and right here. Right, where it crosses the x-axis, right? X-intercepts. One solution, okay, well, we could have this. It would only touch one point on the x-axis. So maybe right there, it looks like it just touches that one spot on the x-axis. So that could be one. And these could open downward too. I'm just being boring and making them all open up. Here, I'll make the last one open down. No solution, right, would be if that parabola, which could be the worst parabola I've ever drawn, doesn't even touch the x-axis, right? It doesn't meet the x-axis, so this one has no solutions. Okay? Awesome. So let's go ahead and look at some graphs. And as I said the other day, we can hand graph these. I think that's good to know how to do, okay? But we've got technology on our side. And we could spend a week just hand graphing these, but why bother when we have these really cool calculators and everything else? So here's what I want you guys to do. So let's go ahead and I want you guys to graph number 1 and number 2 and number 3, right? Graph those. If you want to fill out the table, you can. We don't need to pick, X values, plug them in, figure out what Y comes up, and then graph it from there, right? Let's put this in. Let's get good at our calculators. Let's put this into our calculators. If you want to fill out the table, you can. But do that. If you're still a little bit stuck on these, again, put the quadratic, right? Put that function into the calculator, hit graph. If you need to trace it, we can do that. So when you come back, I'll have my 3 graphed here, and then we'll talk a little bit about them, and then we'll go from there. Okay? So go ahead and graph those 3. Okay, welcome back. Hopefully your graphs look very similar to mine. I went ahead and filled in the tables. Just because I did, because I got nothing better to do. But anyway, again, if we were graphing these by hand, of course we could figure out axis of symmetry. We could plug in our numbers. Once we have half of it, we know that reflects over, all that fun stuff. Anyway, today is all about roots, zeros, solutions, x-intercepts, right? So these are the answers, right? When we solve this quadratic equation, which we will eventually, right, on number 1. So when we solve x squared plus 4x minus 5, we'll find that it has these 2 answers, right? Well, what 2 answers does it has? Well, as we zoom in on the graph, right, where does it cross the x-axis? So it crosses at -5 and it crosses at +1. So those are my 2 solutions, right? We can all remember how to draw awesome curly brackets. So over here, I would say my solution is -5 and +1. That is a terrible left curly bracket, but a pretty awesome right curly bracket there. You could also just say, hey, x equals -5, comma 1. That works too. Okay, nothing wrong with that. Curly brackets are just the same thing. Let's look at number 2. So where does this one cross the x-axis? Again, this is one of those one solution ones, right? It barely touches, it looks like all the way down here at 1 on our x-axis. So this just has one solution, and it happens to be where the x value is equal to 1. So let's go ahead and we can write that in there, and we can just say 1, right? Or if you were just wanting to put x equals 1, that's okay too. And then the last one down here, let me move over here so you can see it. Again, this one doesn't even come close to intersecting the x-axis. Of course, it goes through the y, but that has no bearing on here. So this one has no solution. So we can write that a couple different ways. You can write that curly brackets 0 with a line through it, right? That means a null set. Or you can just say no solution. You could write that out. That works. That works out too. So, all right. So there's our first page. Second page, more of the same. So there's the first three. So hopefully those were tons of fun. Why don't you take these next three? All right. I think all of these will have solutions. So again, graph them however you want to. I think as long as we've got technology, we might as well use it. So let's use our calculators to make a good sketch on 4, 5, and 6. All right, when you come back, I'll just have the graphs in there on these ones. I won't go through the tables and all that. And then we'll go through the solutions again. And then if you take a sneak peek down here, we're going to talk about some weird thing called the discriminant, whatever in the world that means. And then we're going to be done for the day. Today was an easy day, only because we get to use our calculators to graph everything. So pause this, give 4, 5, and 6 a shot, and we'll go from there. Hola, welcome back. Okay, so here's what I have for my awesome looking graphs here. So number 4 looks like it has 2 solutions. Again, where does it cross the x-axis? I'll just put my answer over here. So this would be 2 and 8. All right. So there's our 2 roots or 2 zeros for number 4. Number 5, again, 2 more zeros here. -3 and 3 appear to be the 2 for that. And you'll notice we're getting really nice whole numbers, right? Eventually we won't get good numbers. And you know, the trace feature on our calculator might not work as well as we want to, but remember, we do have a calculate button on there, so it'll find the zeros for us. While all of these happen to be nice whole numbers, sometimes that doesn't always work out. All right, number 6, again, 2 really nice ones there. It looks like 0 and +2. Okay. So let's move on to this weird word that I alluded to. And we have this thing that we call the discriminant, right? And we use this to figure out how many answers, how many solutions there are to a quadratic, okay? And so here, so the discriminant, let's say used to determine number of solutions, right? How many solutions as I run out of room. There we go. Okay. And just like we had for the axis of symmetry, right? We had the opposite of B over 2A. Okay, remember, A and B, even C, they all relate to numbers, coefficients, if we will. We have a handy-dandy formula that we use for the discriminant, and it looks like this. It's B squared minus 4AC. The discriminant is actually part of the longest formula in the entire world, the quadratic formula, that we will use here in just a week or so. All right, so we'll see this b squared minus 4ac pop up in that. But for now, the discriminant will tell me what kind of solutions, not really what kind of, but how many solutions that we have. So when we evaluate this b squared minus 4ac, right, we're going to get a number, okay? All 3 scenarios are listed right here. One of 3 things will happen. If this discriminant evaluates to 0, so in other words, I square b, I subtract it from 4 times a times c. If that turns into 0, then we have exactly 1 solution. Okay, if that b squared minus 4ac, when we evaluate it, if it's a number, any number, right, greater than 0, 0.1, right, 0.0004, okay, we know that we will have two solutions. And if we get any number less than 0, negative numbers, okay, then we know we will have no solutions to that. Okay, so really we can think of negative numbers give me no solutions, positive numbers give me 2, and if it's 0, we get 1 solution. Okay, so here's how this works. And let's write over here just standard form for ax squared plus by plus c. So here's standard form. Here's where we get a and b and c, right? A is the coefficient of our quadratic term, b is the coefficient of our linear term, and c is just our constant. We're going to use all of them in here. If we don't have a number, right? If we don't, like if you quickly look up here on number 6 that we just did, this graph up here, all right, you'll see we have a quadratic and a linear term, but I don't have a constant. If you don't have a number, right, whether it's linear or constant or a quadratic, we use the number 0 for that, okay? That'll happen every now and again. I don't see it happening here on number 7. So let's take a look. All we want to do is figure out how many solutions this has. We're not solving it, we're not graphing it, we're not doing any of that fancy stuff. Let's just figure out on x squared plus 5x plus 4, how many solutions does it have? So my discriminant is b squared minus 4 times a times c. So this looks like 5 squared minus 4 a. There's an invisible 1 there in front of x squared, so there's your coefficient. And c is 4. I almost said 5. Whew. Let's evaluate a little bit here. So this turns into 25 minus, I believe that to be 16. And we keep evaluating, and we get the discriminant is equal to 9. Because it's equal to 9, we will have 2 solutions. Okay, it's that, it really is that simple, guys and gals. It's that easy. Okay, let's check out number 9. So x squared plus 10x plus 25. Again, you're going to use a formula. You might as well write it down. B squared minus 4ac. So b value is 10 squared, and we're going to subtract 4 times a, which is 1. C is 25. Okay, 10 squared is 100. 4 times 1 is 4. 4 times 25. Ooh, sweet. I got this problem here. So discriminant is equal to 0. Because it's equal to 0, this means 1 solution. Think about what this would look like on a graph, right? If we graphed this one, this is one of those where it just touches our graph in just one spot along that x-axis, okay? All right, number 11. Onward we go. B squared minus 4ac. And believe me, I know this calculation seems simple. When we put it into the quadratic formula, this is the one thing that we will struggle with the most, right? It's because you either have to think of this. I think it's easier, kiddos, if we just leave this subtraction sign alone and take 4 times a times c. And if you get a negative number, put it in parentheses, because then you're going to have a double negative and all things are happy. Anyway, off we go. Negative 12 squared minus 4 times 4. Finally, a coefficient there other than 1. And my c value is 9. Okay. So negative 12 squared, 144. Let's see, 4 times 4, 16. 16 times 9. Let's see. I don't know, 100 and... Hold on. And let's see. This is, wow. This is tough. I should have had a calculator handy with me. That is 144. Okay. So discriminant equals 0. Because it equals 0. Again, this is another one of those 1 solution. Okay. All right, your turn. So you guys tackle the evens there, 8, 10, 12. So have a free run at those, and let's see how we do. No bear traps there, really, for the most part. We've got 3 values or 3 coefficients for A, B, and C. So go ahead, give those a try, and then when you come back on like magic, everything will appear. Okay. Glad that you're back. So here you go. So 8, 10, 12. We had negative discriminates on 8 and 12. So that means no solution. 10, we did have a positive discriminant greater than 1, so therefore 2 solutions. All right, so there we go. So there was today. So today all about understanding that where our graphs cross our x-axis, we call those things solutions, zeros, roots, intercepts. We have this crazy thing called the discriminant, and all I have to do is plug in my A, B, and C values into that formula, and I don't even need to graph it. I can tell you right off the bat how many solutions that will be, and that will be particularly useful here in the days to come. So as you can see, we do have a little bit of homework tonight. It shouldn't be too bad. Again, if you need a graphing calculator, don't forget about Desmos. All right, that one is it's just an app, and it graphs everything very, very awesome for us. So let's do all 1 through 15 today, and be super nice for Mr. Trissel the rest of the time. He was inducted, by the way, into the Canton South Hall of Fame on Saturday. So you're being taught today by a Hall of Famer, right? Mr. Trissel. So anyway, hope all is well, and I will see you guys tomorrow, again, 1 through 15 on the homework. Have at it. See you guys.